Greetings and hello everyone, it's Dr. Wood, and today I want to talk about some types of variables you may run into in the research, the literature you're going to be looking up for your project. Keep in mind this is just review. Some of you may have forgotten some of the more salient points here since we had EpiBio together, but I want to remind you of things you're probably going to commonly see in the literature out there. First off, two ways we can describe our variables are going to be independent and the dependent variables. Generally, research papers will be set up to where they may not explicitly state what the independent and dependent variables are going to be, but it's important to be able to delineate between the two of them. Remember, the independent variable is the thing that the experimenter is going to be assigning. Basically, that's what they're going to be changing. So if you're comparing, say, two different doses of a medication, that would be an independent variable. If you're setting up men versus women, or say, red versus blue, those are independent variables that the researcher is setting up themselves. Again, we can manipulate that, and based on that change, based on how we're assigning our groups there, it should have some effect on the dependent variable. The dependent variable is going to be the outcome. So as an example, if I were, say, trying to dose lisinopril 5 milligrams versus lisinopril 10 milligrams, that would be an independent variable. The outcome would be my blood pressure change, right? That would be the dependent variable there. In studies, you may find you have multiples of each, right? You may be able to delineate groups based off several independent variables. You may also have several dependent variables or several outcomes that you may be measuring there. Okay, so it's important to be able to distinguish between those two there in any given paper. Next up, when you're actually getting into the types of variables, we have three main varieties. We're going to talk about nominal, we're going to talk about ordinal, and then we'll talk about continuous. And there's some further breakdowns from there. But starting off with the nominal variables, just like it implies with the name, they're basically kind of a named category, right? So these are going to be things where you're going to find there's no direct relationship or difference in magnitude between the different groups there. It's kind of like saying I have A blood versus B blood, right? One's not better than the other necessarily. They're just different, right? They're different categories there. There's no particular ordering to them. There's no particular change in magnitude there, right? Again, you can have multiples. So example, you could have something like eye color, which has multiple different varieties there, blood typing, as I mentioned. If there's only two, you would consider that a binomial or a dichotomous variable, right? So alive or dead, yes or no. Again, no consideration for order or magnitude there, right? And again, usually they're not going to be numeric, right? So yes, no, live, dead. Gender, actually, used to classically be considered a dichotomous variable, but depending on which circles you're looking in or how your research is actually categorizing it, you may find gender is not a dichotomous variable. You may find they have, male, female, transgender, etc., right? So you can break that up in several different ways, okay? Moving into the ordinal variables, you're going to find now that there is an order, as the name implies, to the different categories, right? You may not be able to, expressly distinguish the order of magnitude between them, and it could be different, right? Between, say, poor to fair and fair to good. Like, how do you really kind of quantify that difference there, right? Or for instance, say you're looking at, different stars on a restaurant. Well, what's the difference between a 2-star and a 3-star restaurant? It may be hard to quantify those sorts of things, which is why that we call that an ordinal sort of variable there, right? So also as an example, when you do your evaluations for your professors and your classes, that is going to be an ordinal scale, right? When you're saying, well, how much do I disagree or agree with this statement? That say my professor is super awesome, and you would obviously say I strongly agree with that. But again, if you were to say agree versus strongly agree, there's not necessarily a consistent difference between those values. And then finally, you're going to get into the continuous variables. This is going to be the most, you get the most utility out of this one. You're going to find this is probably used most commonly. And again, it can represent anything that comes as a numeric range. Again, the order of magnitude of difference between value to value is going to be consistent throughout. So for instance, if you're looking at blood pressure, that change in blood pressure from, say, 100 to 110 is going to be the same as it would be from 110 to 120, right? Weight, temperature, looking at things like, trying to think of any other good ones off the top of my head, but I'm running a blank now. But there's lots of different continuous variables there that you run into. Temperature, as I mentioned, as an example here. Lots of different ones. So, and these are the things you're going to find probably most frequently in the research articles you're going to be looking at. Yeah. Okay, so further breaking down continuous variables here, you'll see with interval variables that this is where it's continuous, right? You just have the same order of magnitude between different values here, but you're going to find the 0 point is not really considered all that meaningful. So as an example, temperature in Fahrenheit or Celsius, you can have negative values there, and that's okay, right? IQ is another one where you what's an IQ of 0, right? It's really hard to get that, and so you can take differences between those, right? So I can measure two different temperatures and subtract one from the other. That makes sense. I can do some evaluations of that, but you can't really do like ratios and things like that between. I can't divide or multiply those values together because the 0 point doesn't really make any sense. Okay, so you're going to see interval variables used occasionally, but not super commonly. Just to give you an example, though. Looking at temperature, say for instance in Celsius, 0 degrees Celsius does not mean no temperature. It just means you're at the 0 point for the Celsius scale. And similarly, looking at 100 degrees Celsius is not twice as hot as 50 degrees. It's a little bit more arbitrary because that 0 point doesn't really make any, it's just arbitrary, right? We just kind of placed it there. On the other hand, though, looking at something like Kelvin, where you have absolute 0, which means absolutely no energy in the system, that would not be considered an interval variable because the 0 point there is meaningful. Now going into the ratio variables, this is where the 0 point is meaningful, and we call them ratio variables because you can do ratios on them, right? So as an example, blood pressure, right? You can have 0 pressure, and so you can do things like compute ratios between the two. You can look at the differences between the values and all of that. So again, body weight, mass, distance, blood pressure, temperature, and Kelvin, all those are really good examples of ratio variables. And again, that's important to know the difference because you'll be able to make different interpretations about that. And again, in terms of calculations, this will be a little bit more robust because you can do things like ratios. I can divide one by another. Some different ways we can describe the data here. You'll find that the mean or the average, most of you know what that is, basically taking all the values in a data set and dividing them by the number of observations. Pretty easy to come up with, right? So if I have 4 tests that I take and I make between 100 and say a 50 on those tests and I average them out, you may end up with a 75 average. Okay, pretty straightforward. Now when you're dealing with things like non-parametric data, which we'll talk about in another video, or if you're dealing with something like an ordinal variable, oftentimes you can't really calculate a mean, or it may not be really reasonable to do so based on the data. And what you'll use instead is basically a median, which basically means if you take all the observations, all the values, and you line them up from smallest to largest, that middle number, that 50th percentile, would be considered your median. Okay, and so we'll talk more about those a little bit later when you're going to use one versus the other, but that's what we consider to be the 50th percentile. Okay, mode is just a number that is going to be that shows up most often. So if I again had a number of observations and say the number 50 turned up, the majority of times, you'd find that would be the mode, right? The most common number that pops up in that data set. Range is just going to be from your smallest to your largest value there, kind of that difference. You get the total range. And then another very common thing you'll see being used, especially with medians, which again I said median is the 50th percentile, would be the interquartile ranges. Basically, that just means the 25th and the 75th percentile. Okay, the reason why we use these is because you'll find when we're using data that requires use of medians and things like that, you're going to find that we want to try to get rid of the effect of the outliers, and so this is a better way to describe that data there. So if you see an interquartile range, that's typically talking about between the 25th and the 75th percentile. Now, looking at this table here, I think it's handy because it kind of gives you an idea of what sort of values you're able to use and what type of variables you can use in order to, what kind of computations you can do on them, essentially, right? So here you can see you have nominal, ordinal, interval, and the ratio. Remember, both of these, interval and ratio, are going to be considered continuous variables. Again, intervals where the 0 point does not matter, ratio is where the 0 point does matter, okay? Now, frequency distribution. This is easy. You're just counting values, right? You can do that with any type of variable, whether it's nominal, ordinal, etc. Okay. Median and percentiles. Okay, with nominal, you can't really do a median because it's usually like a yes/no sort of thing. There's no ordering between the two, right? Dog, cat versus horse versus pig. There's no real differences in terms of one's bigger than another, unless you're comparing actual sizes, but in general, you wouldn't say one's better or worse than the other. In those cases there, you can't really do median and percentiles with nominals. However, when you get into ordinal variables, again, there is an implied ordering to them, right? Very poor is worse than poor, which is worse than fair, right? You can start to get into medians and percentiles. And you can certainly do the same with interval and ratio variables. Okay. Getting into adding or subtracting, you will not be able to do this with ordinal variables because, again, there's not an implied magnitude of difference between the different categories, right? So again, it's hard to really apply a number of difference between, say, very good to good and good to fair. And so because of that, I can't really add or subtract those values. Okay, you can though with any continuous variable. Doing ratios, again, you're going to see this is more restrictive to where you can only do that with ratio variables there, with only with continuous variables where the 0 point actually matters. Okay, and then finally getting into our means, standard deviations, and whatnot. Again, we're not going to really focus so much on the standard deviations and standard error of the mean, but the mean, I certainly want you to know, again, those can be calculated with any continuous variable, whether it's interval or ratio. So that's it for the type of variables you're going to run into most commonly. Again, this is not all comprehensive, but it is the most common ones I want you to be familiar with. And if you have any questions, let me know, and I'll see you next time. Thanks a lot. Bye.